Welcome back. Today we will be talking about the law of cosines, and they are also valid for the oblique triangle. So if you remember, with law of sines we talked about the four conditions. So the remaining two conditions will be solved with using law of cosines. So SSS and SAS. So these are the formulas. The one is the standard form and the alternate form. Standard form is used for the sides, and the alternate form is more convenient for finding the angles. So can I prove the standard form and the alternate form? Let's try to prove one. So we have a triangle A, B, and C, and let's define the coordinates. So the altitude is written as y, and one side, that means the left triangle, has the base of x. So these are labeled like this, and B has the coordinate of c comma 0. So to start with, if we are talking about x, x is nothing but b times cos A, because we are using SOHCAHTOA for the left triangle, and y is b sine A. So if I have to find the distance between C and B, I need to use the distance formula. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. That will give you this lovely equation. And if I square both sides, I will get x minus c whole squared plus y squared. Let's replace x and y with the given equation, b cos A and b sine A. So if I replace them, we are getting b cos A minus c squared plus b sine A whole squared. Let's use a minus b whole squared property. And if you open it up, it will, the parentheses, it will give you this lovely equation. Let's combine the like terms after this. So we have b squared cos squared A and b squared sine squared A. I can combine these and take out a b squared, and that will be just a Pythagorean theorem of trig. So cos squared A plus sine squared A will be just 1. And the leftover will be our standard formula for A squared. In the same way, you can derive for the b squared and c squared. So this derivation, it is just for your understanding. You don't have to memorize it. It is just, if you know, if you have the understanding of it, it will be a little bit easier to memorize them. Okay. How I memorize these is that a squared, if I have to find a squared, in the equation there is no a involved, only angle A will be involved. So similarly, you can prove for b squared and c squared, but remember the standard form and the alternate form. So alternate form is used for angles. Let's take one example. So this example is for side, side, side. So if all the three sides are given, so we have C, and then C is right there. And so if all the three sides are given, what they are asking for, to use the alternate formula to find the angles. So we need to find three angles. So we will use cos A, cos B, and cos C. So this alternate form is derived from the side, the standard one, the one that is used for the sides. It is just isolating the angles. So we have a squared plus c squared minus b squared divided by 2 times a times c. And the same way I can write for cos A, because we are talking about cos A, we are not including the side A. With the addition, its side A will be included with the subtraction. For cos C, side C will be included with the subtraction, right? So there is a pattern. You just have to look at the pattern. We have all the numbers that are given. Let's plug them one by one. And after putting it in the equation, just put it in your calculator or do it by your hand, and you will get cos B, cos A, and cos C. After getting cos B, cos A, and cos C, that is not your final answer because I need the angles. To get the angles, what we are looking for? We are looking for inverse, taking the arc cos. So let's quickly write it down. What will be the value for cos C, and then we will take inverse. So these are our final values for cos A, cos B, and cos C. Now let's quickly take the inverse to get the angles A, B, and C. So inverse will give you angle B Let me write all the values first. Okay. Now angle B after taking arc cos will give you approximately 36.34 degrees. Angle A after taking cos inverse will be 26.38 degrees, and angle C after taking cos inverse will be 117.28 degrees. Let's take another example. In this case, two sides and the included angle is given. So this is the case of SAS. So angles and sides. So we need two angles and one side length. So let's start with finding the side length. So we need to find A. So A squared will be plugged in with this formula, the standard form, and just put all the information in. Cos 80 degrees, because that is the angle that is given. If you solve it, you will get 333.3, but that is the squared, so take radical both sides. So side length A is 18.25, and this is the longest side length because B is 16 and C is 12. So if this is the longest side length, that implies angle A is the largest angle in this triangle. Because if you remember from geometry, the side opposite to the largest angle will be the longest side. The side opposite to the smallest angle will be the smallest side. So if I use the alternate formula of law of sines, I can find the angles. You can also use the alternate formula for cos as well, for law of cosine, but it will be convenient here to use law of sine. So it is okay to use law of sine and law of cosine combined together in one problem. So we are using the alternate formula, that means the reciprocal formula, sine A over A divided by sine is equal to sine B over B. Sine A is given as sine 80 degrees, and we just found the side A, and side B is already given. So if you do cross multiplication, you will get sine B is equal to 0.863, and after that we can take inverse. So if you take inverse, angle B will be 59.69 degrees. Now, because it is less than 180 degrees, there can be another degree as well. So another angle, another alternative angle as well. So let's say possibly the angle B1 is for 59.69 degrees. Then B2, the another alternate angle B2 could be 120.3 degrees. But that is not the possibility because we just calculated that side A is the longest side length. That is why the angle A needs to be the greatest angle. So angle A, that means 80 degree, is the biggest angle in this triangle. So we will just take angle B as 59.69 degrees. In some cases, you might need to take B2 as the given angle. So it will depend from question to a question. So we are considering 59.69 degrees for angle B. Now we have angle A and angle B. Let's calculate angle C. Sum total of a triangle is 180 degree. So keeping that thing in mind, angle C will give you approximately 40.31 degrees. So we solved two angles and one side length. Let's take one word problem. So one word problem is given, the images is given. So if you look at the image and read the word problem, we are given the side length length F, side length P, and the angle in between 45 degrees. So this is the case of side angle side, because angle is sandwiched between two side lengths, right? And they are asking for how far is the pitcher's mound from the first base. So let's start calculating. We need the side length h, because if I have the side length h, then things will get a little bit easier. So h squared will be the sum of the square of the two sides minus 2 times the two sides and cos h. We have all the information given. Let's plug it in. So that will give you approximately h squared as 1800.3, or h is 42.43 feet. Let's take one more example. This is with the bearing. So if you remember in the last unit, we talked about the bearing. So it says 40 miles due east and then changes direction, and then 30 miles in the new direction. And then they also said 56 miles from its point in departure. So all the side length is given. So that means this is a case of side, side, side. And they are asking you describe the bearing from point B to point C. So because we have to talk about the angles, we are using the alternate formula for law of cosine. So they are pointing from point B to C. That means we need to find out what is angle B. So that for that we use cos B, formula for cos B. Let's put all the information in. All the information is given. And if you solve it, you will get approximately negative 0.265, and after that we will take inverse to get angle B. So if I take inverse, you will get angle B as approximately 105.37 degrees. Now that is not my answer because they are asking for the bearing. So bearing, if I have to find the bearing, because it is not, we are not talking about the 90, how it is shifted from 90. So 90 plus 15.35 degrees will give you 105.37 degrees. So 15.35 is my bearing, but in what direction? North 15.35 degrees towards east, right? Because that is the scale that is given for the direction. So from north, it is moving towards the east. Now, keeping that thing in mind, the another thing that we would like to discuss is about the Heron's area formula. So Heron's area formula, we have a triangle. We are talking about the oblique triangle again. We have the side lengths. So all the side lengths are given. So the basic structure of Heron's is to find S. What is S? S forms the basis of it. So we add all the sides and divide by 2. And area is calculated with this formula, radical of S times S minus A, S minus B times S minus C. So these two formulas are very, very important if the question is asking for the Heron's area formula. And how to identify whether I need to use the Heron's formula or not, I will discuss it later. So let's take one example. All the side lengths are given A, B, and C. So my first line of action to use the Heron's formula is to find S. S is the adding of all the three sides of the triangle and dividing by 2. Yes, it is not the average. We are dividing by 2 only. So S will be 5 plus 9 plus 8 divided by 2. That will give you 11. Once I know what is S, let's plug it back in the area formula. So area is radical of 11 times 11 minus 5 times 11 minus 9 times 11 minus 8. So I miswrote 11 minus 9. It should be 11 minus 8 because C is 8. If you solve it, you will get 19.89 square units. Because remember, area is represented in square units. Now, how to understand where I need to use the Heron's formula and where I need to use the another formula that we used for law of sines. So law of sines, we are using these formulas, the first two condition of law of sines. Heron's formula is used when we have the case of law of cosines. Right? There are two cases of law of cosines. So Heron's formula is used for SAS and SS. For SAS, we are using the law of sines, but when all the sides are given, we are using Heron's formula. That means for side, side, side. So these are the important things that you need to keep in